Welcome back everybody to another video from Mrs. Semino. Tonight we're going to be covering types of reactions. I'm hoping to go through this video pretty quickly because we will also be covering these reaction types in class. And if you're still struggling after doing the activities in class and getting the lecture and watching this video, then make sure you do this reading that they're suggesting here in your textbook. It'll help out. The two big things that you want to make sure that you're getting from tonight's lecture is that you're able to identify the reaction type. So if you were to see an equation, you need to be able to use one of these terms we're going to talk about and say, okay, that's a combination or a combustion reaction. Then you also will need this video to help you make predictions about the products that are produced. So you probably remember from the quiz that we just took on balancing chemical formulas that you often have to write the formulas. So now what we're going to do in this chapter is, the second half of this chapter is I'm going to give you the reactants and you're going to have to come up with the products, and knowing about these different reaction types will help you make better predictions and come up with the right products for your equation. So the first type of reaction that we're going to talk about is the direct combination, or sometimes it's called the synthesis reaction. And this is where we have two or more reactants that come together to form a single product. And a good big clue here that it's a synthesis reaction is that you only have one product. And so what we're going to see tonight is you're not really going to see like a lot of chemical formulas. You're going to see these generic letters. So if I have X and I have Y, they're going to come together. There should be this big yield symbol here to form XY, so that these two are combining together to form XY. Here is a classic example of a direct combination reaction. We take our hydrogen, look, it's diatomic, chlorine is also diatomic, together with our little yield symbol that's obviously not showing up on the PowerPoint, to produce two hydrochloric acids. Also notice that we've included these symbols, so especially for honor students, you need to be paying attention to these solid, liquid, gas, states of matter symbols. So just a little bit more about the direct combination or synthesis reaction. Again, we have X and we have Y, but notice that right now you might think, oh, they're just elements, okay? They could be elements or they could be compounds, either one. And then XY, of course, has to be a compound, because if I have two elements that are bound to each other, it's going to be a compound. Tonight's lecture will definitely be talking about 5 main types of chemical reactions, but along with each main type, there's what we might call subtypes or different kinds of those reactions, and knowing about these other kinds will help you make better predictions about the products. So the first thing I want you to know is that metal oxides and water will always form metal hydroxides. So calcium's a metal, oxygen, here is our oxide, along with water is going to form a metal hydroxide. OH is our like little hydroxide polyatomic ion. And just so you guys know, like the subscript down here should be a subscript, not behind it. So the first type of synthesis reaction, metal oxides and water, will always form metal hydroxides. The next kind that we need to know is that if we have a non-metal oxide, and so here we can see carbon is obviously not a metal, along with its oxygen, and water will form an acid of the non-metal. So again, non-metal, oxygen, water, going to form a acid with the non-metal. So notice we have the H2, CO3 here, forming the acid. Also pay attention, notice that we have this AQ here, and the AQ really should be over here, but we're saying that it's been dissolved in water when you see this notation. Now the next main type of reaction we're going to talk about is decomposition. So let's just think about this word decomposing, breaking down. So we have a single compound breaks down into two or more simpler substances. Now we only have one reactant. I like to think about this one like the opposite of the synthesis reaction. So we only have one reactant breaking down into two simpler things. A classic example here is where we take water, we add electricity, I should put like electricity on the top here, and it produces two hydrogen molecules and an oxygen molecule. So it decomposes, water breaks down into hydrogen and oxygen with the help of electricity. So again, coming back to these, what are these things meaning? So XY is obviously going to be a compound, and then X and Y could either be an element or a compound. So hopefully you're noticing that this is like just the reverse of the synthesis reaction. So the first type of decomposition reaction that I want to point out is if we have a metal carbonate, it's going to decompose into a metal oxide and carbon dioxide. So you'll actually see this one quite often. So here's our metal, here's our carbonate. It's going to decompose into our metal oxide, so again, metal with oxygen and carbon dioxide. I hope that you guys are like writing down each one of these main types and then the different kinds of each type of reaction. Another type of decomposition reaction that we might see is if we have a metal chlorate. It's going to decompose or break down to form a salt and oxygen. So here is our metal, potassium. Here is our chlorate. It's going to decompose into our salt, which is potassium chloride. I know when we think of salt, we think sodium chloride, but remember this is like in the same group. So we still call this a salt. And then our oxygen. Now the next main type of reaction we're going to talk about is the single replacement. You also might hear this called a displacement. So replacement, displacement means the same thing, just depends which textbook you're reading. And this is where we have one element replaces another in a compound. And so we have two, I guess, different kinds of single replacement reactions. We can have it where a metal replaces a metal, or we'll see on the next slide where we have a halogen replacing a halogen. So remember, the metal is considered a cation. So this is our metal, okay? This is our thing that's going to be replacing this. And so on this side of the reaction, you can see that the M is lonely now, and the X has hooked up with Y. Okay, so I mentioned that we also can have it where we have a non-metal replaces a non-metal, and usually these are halogens, although not always. And so again, so we can have the anion displacing the other anion. Classic example of a single replacement reaction is we have copper and we have silver 2 nitrate. The copper displaces the silver, leaving silver by itself. The copper now has attached itself to the nitrate. So on this slide, I just want to talk about this thing called the activity series. So what we need to do is we need to have the free element must be more active than the element that it's going to be replacing. So if we look at this general thing here, we have A trying to replace B here. Okay, so notice that A is now hooking up with C over here and B is by itself. So the way that this works is for this reaction to occur, if on our activity series that we have on our periodic table, if this is the top of the table, this is the bottom, this means it's more like reactive up here, okay, more reactive. This is less active down here. So A would need to be higher on the activity series than B for the replacement to work. So here's just a couple of examples. So we have iron and copper sulfate. So look on your periodic table and hopefully you'll see that iron is higher on the activity series than copper is, so this reaction will take place. So notice copper is kind of all by itself again, and the graphics aren't looking really good here, but hopefully you're getting the idea. But then if we look at gold and we look at copper, gold is actually beneath where copper is on the activity series, so there's no reaction that's going to be taking place. Now the next type of reaction that we're going to talk about is called a double replacement reaction, and again it could be considered a double displacement reaction depending which textbook you're looking at. So basically the ions in two compounds change partners, and so the cation of one compound combines with the anion of another compound. So notice we have AB, and just for the sake of it, that's going to be a positive, that's going to be a negative, and we have compound CD here, again positive and negative. And so when the reaction occurs, notice that the positive hooks up with negative D, the positive C hooks up with the negative B. They've just switched places, and that's what happens in a double displacement or replacement reaction. Here is a classic example of a double replacement reaction. Notice the lead starts off over here with the nitrate, but if you look on the product side, lead has hooked up with the chromate over here. Over here we have the potassium and the chromate together, but they've just switched places and now the potassium's hooked up with the nitrate over here. Now, just like we had to worry about the activity series with the single replacement, there's a couple of special things we need to pay attention to with the double replacement reaction here. So we just want to remember that the ions are just replacing each other. And one of the products must be insoluble or form a precipitate for the reaction to occur. So one of the things that we're going to be using in class is that solubility table that's on the back of your periodic table. So again, we notice that we have our lead nitrate, we have our potassium iodide here. When it forms, okay, when they switch places, we would have lead hanging out by itself and potassium nitrate. So notice that it's got the solid here, so we have the precipitate. On the other hand, if we had sodium nitrate and potassium iodide, there's really no reaction because they're both soluble, so we don't have the double displacement reaction occurring here. So I'm generally going to recommend that you use your solubility table. It's just a good reference or a tool, but your textbook will also talk about these different solubility rules. So if you're curious about a specific one, go ahead and check it out. Also, in a double displacement reaction, we can have a reaction between an acid and a base, and so which the base is a hydroxide. So notice we have sodium hydroxide and an acid. They're just going to go ahead and switch places and produce water. So this is like a big one that you may see like on your tests or your quizzes about trying to figure out like, well, hey, what is this going to produce? This is what throws everybody off is this this hydroxide here, which has a negative charge, hooks up with this hydrogen, which has a positive charge forming water. So this is the product that everybody kind of seems to not be able to figure out. And the last type of reaction we're going to talk about is a combustion reaction, and this is basically just where something's getting burned. So we have something with oxygen, and it's going to break down. I kind of think of it like breaking down or burning, and it's always going to produce carbon dioxide and water. I love this because whenever I see oxygen by itself, I'm like, bam, I know that the products are going to be carbon dioxide and water. So again, the products are always carbon dioxide and water for a carbon-based fuel. So look, we have CH3, so we have a hydrocarbon here reacting with some oxygen, producing carbon dioxide and water. Okay, that's all I have for this evening. Again, I hope that you wrote down each of the main reaction types along with the kinds of reaction types that there can be in order to help you make better predictions about products. Good night.